Bismillahirrahmanirrahim. We will be continuing class on exponent, and this is third class or third lecture on exponent, and we will be doing today laws of exponent. Laws of exponent, we will be concentrating on two laws. One is called product rule or rule of multiplication of exponent, right? So what this rule says? This rule says that when multiplying like bases means if I have one a here and one a here, both of them has got the base as a, but their power are different. Let's say power of a is x here and power of a is y here. So what my rule is saying? Law of exponent, first rule, product rule. When multiplying same bases or like bases, the powers are going to be added. Add the exponent. So keep the base same, and add your powers. Here in this example is x and y. So I add them together. So if you have any number, for example, 2 to the power 2 times 2 to the power 3. So what I have to do, I have to keep the base same and I have to add the power. So 2 plus 3. So my answer will be 2 to the power 5. Or if I have the variables like x to the power 5 times x to the power 6. So base is same, x. What I have to do, I have to add the power, 5 plus 6. So x to the power 11. So this is how we deal with the product rule. So you have to be clear about this rule that if you have the base same, then you can add the power, right? So we write this rule as a to the power x times a to the power y. And what the rule says, keep the base same and add the exponent. So we add the exponent. Dividing rule or quotient rule. It's also the second rule is dividing or quotient. So quotient rule or dividing rule is if the bases are same and two things are getting divided by each other, like for example a to the power x divided by a to the power y. I can also write it as like or a to the power x divided by a to the power y. So we have to keep the base same again. So I will keep base same and subtract the power x minus y. So when dividing like bases, keep the base same and subtract denominator exponent from the numerator exponent. So I subtract it, right? So x minus y. What it says? So we have the definition and we have the symbolic rule, right? So this is symbolic and that one is the descriptive definition of laws of exponent. First law says product rule. Second law says quotient rule. What is product rule? Again, I am repeating. If like bases are being multiplied, keep the base same and add the power. So we are adding the power. Now we have the quotient rule. So if we have the same bases, what we have to do, keep the base same and subtract the powers. So what will be subtracting? Subtract denominator exponent from numerator exponent. So denominator exponent is y. So I subtract it out. So for example, if I have something like x to the power 6 divided by x to the power 3. So that means I am saying x to the power 6 and x to the power 3. And my law is saying that you have to subtract the denominator power from the numerator power, which will give you x to the power 3. So that is my answer for this particular example. So you can take tons of examples here to understand the things clearly. So I will repeat it again. And then there will be a bigger questions and you have to see what is, for example, if I say 3x square y square divided by, or I can take bigger power, 6, right? And here I have x and y. y power 3, right? So what we have learned here with the definition, so 3 is only 3, so this is just a number. But what is happening with the exponent or the variables? So here I have x power 2 in here in the numerator, and I have to subtract the power of the denominator from here, which is 1. And then I have to see y. Y has got 6 here and 3 here, so I have to subtract these power, 6 minus 3. So my answer will be 3x y to the power 3. This is my answer for this particular example, right? So we have to see another example. Okay, so if we have like 45 p cube q cube divided by 5 p and q, right? So number will get cut with number like the quotient. We know that we can cut 5 and 45. They are in the same table of 5. 5 9s are 45. So 9 will be here. But for the variables, we have to use the law of exponent. So law of exponent is saying that I have 3 there, and you have to subtract the power from the denominator. So I have denominator 1, q I have 3, and in the denominator I have 1. So I subtract it out, and my answer will become 9p to the power 2 q to the power 2. So this is how we deal with the quotient rule. So quotient rule is saying that subtract the power, right? And product rule is saying that you have to multiply the, if they are multiplying, you have to add the power. So let's see another example where we have to do both things, like where we have to do multiplication and addition, right? So, or subtraction, sorry. So what I was saying, a to the power x and a to the power y. And what the rule is saying? Rule is saying that keep the quotient same and subtract the power, x minus y. So if I have some question like this, that 5x 3 times 6x 2 times 3x1, right? And I have in the denominator 3x to the power 3, right? So what I have to see? I have to see that numbers will be multiplying with the numbers. So 5 6 are 30. 30 times 3 is 90. So I have on the top 90. And what I have on the, for the variable x, I have 3 power, 2 power, and 1 power. So I have to add them as per my product rule. So I will say 3 plus 2 plus 1, right? And I have to keep this same for a minute because I have to see, I have to learn that what is happening. So number 3 is getting cut with 90. So 3 ones are 3, 3, 30 is 90. So 30 is my number here. And for x, what I have, 3 power, 2 power, and 1 power get added. 3 plus 2 is 5, plus 1 is 6. So I have x to the power 6. And what I have in the denominator, x power 3. And what my rule is saying? My rule is saying that subtract the power from the numerator power minus the denominator power. So I have got 30x to the power 3 or x cube. This is my answer. So you have to take step by step when you see the denominator having got different base, same bases and different powers. So all those powers will be getting added, because my rule of exponent says that in multiplication, like bases, keep the base same and add the exponent. So I add all the exponent here, 3 plus 2 plus 1, but I have to subtract the 1 which is in the denominator, because the dividing or the quotient rule is saying that you have to subtract the denominator exponent from the numerator exponent. So x minus y. So we subtract them. So we can see another example for this one, where we have to add the power and we have to subtract the power, right? So let's see how to deal with the powers, right? So this was a to the power y. So if I have something like 5c square 3c cube divided by 15c power 2. What I have to do? So I have to deal with the numbers. Numbers goes with number 5 times 3 is 15, and c, same base, c power 2 and c power 3 will get added. So I have c power 5. I can do, like, instead of writing first and then, I can write directly c power 5 divided by 15c square. 15 get cancelled with each other, and I have left with c power 5 divided by c power 2. Now what I have to do? The quotient rule. Both bases are same, so c 5 minus 2. So I am left with c power 3 or c cubed. So this is my answer for this particular example, right? So we will repeat it one more time, that what these two rules are saying. Law of exponent, first rule is product rule. Product rule is when multiplying like bases is important. If they are not like, you cannot do that, right? So if the like bases are there, you need to add the powers. So we add the power as we did here in the example. C power 2, c power 3, so it becomes c power 6. And if something is in the denominator with the same base, that is the quotient rule. So you have to subtract the denominator exponent from the numerator exponent. So we did that because we have c power 5 and the denominator c power 2. So they need to be subtracted with each other as like our rule. And my rule is subtract the exponent of denominator from the numerator. So x minus y, or 5 minus 2. You can see this example, right? So we can take many other examples like the same, but you have to remember the rule. If the bases are same, you have to add the power if they are multiplying, and you have to subtract the power if they are dividing. So if I have x power 5, x power 6, x power 9, and I have x power 3, x power 2, right? So I have a bit of like same bases, right? Quite a few on top, and two of them are in the denominator. So bases are same. So I know the rule, so I will add the powers, right? So 5 plus 6 is 11, 11 plus 9 is 20, so I have got x 20, and divided by x, 3 plus 2 is 5. So I add the bases. First rule is this, that if they are multiplying, their power gonna be added. Now I have to use the other rule here, because now I have same base, one in the numerator, one in the denominator. So I have to keep the base same and subtract the denominator power from the numerator power to get my answer simplified as x to the power 15. So in this way, you can solve any question. A power 18 times a power 2, right, divided by a power 9. How you solve it? So you will say, okay, the bases are same, so I am gonna add the base in the numerator first, which will make me a power 20. But in the denominator, I have a power 9. Now I will apply the quotient rule, and I will subtract the power. So a power 20 minus 9, and that will be a power 11. So this way, you have to practice the two rules, product rule and the quotient rule. Product rule is saying if the base is same, you can add the powers. So you can add the power. You have seen here that I have add the power. Now, if another question is like this, for the same, we are practicing only two rules here, product rule and quotient rule. Then we will go for further rules in the next lesson, so that step by step we know all the rules and we have command on the application of these exponent rules. So now we have to see. Okay, now I have a power 6, b power 6, c power 6, right? And I have here a power 2, b power 2, c power 2, right? So now I have three different bases, a, b, c. So in the numerator, product rule does not apply because the bases are not same. They are different bases. So I cannot say, I cannot add the power. But I can apply the rule here with respect to a power because something is similar, common base here, I can apply the rule here because first thing first is you have to see the base, like base. You have to see the like bases, right? So quotient rule is applying here for a, 6 minus 2, because 6 power is numerator and you have to subtract the denominator power from the numerator power. B, 6 minus 2 again. C, 6 minus 2 again. So your answer will be a power 4, b power 4, c power 4. So this will be your answer. So you have to take care of the fact that first you have to see the like basis. For exponent rules or laws of exponent, talk about only for the like basis. If the base is same, you can play with the power. So if they are multiplying, you can add the power. If they are dividing, you can subtract the power. We can take another example. So this that you have to consider the like basis, and here in this example I had different bases, so we take care of that. Now I have an example for let's say x power 6, y power 6, x power 2, y power 4, and in the denominator I have x power 4 and y power 4. Now, so I have two variables here total. So I will deal x with x and y with y. So x power gonna be added 6 plus 2, which is 8, and y power gonna be added separately, which is 10, 6 plus 4. And in the denominator I have x power 4, y power 4. Now I have to apply quotient rule because now there are something in the numerator and something in the denominator. So what rule is saying? That you have to subtract the power of the denominator from the power of the numerator. So I did this, 8 minus 4 and 10 minus 4, and my answer will be x power 4, y power 6. This is my answer. So we will be seeing other rules in the next lesson. I hope you understand this rule clearly. If you understand it and like the video, please subscribe my channel and press the bell icon button to receive another video. Thank you for watching.